Bismillahirrahmanirrahim. Assalamu alaikum. My name is Mirza Murad Beg and I welcome you all to a new video in a video lecture series of the subject DLD we are studying right now. So today the topic I want to discuss with you is among one of the basic topics which are the basic necessity of the modern world. So everyone wants this necessity, this functionality, and you can say everyone wants is interested in this topic because it is so in today's market, and it is very crucial for every organization and every working firm, everything. Okay. So without further delay, we start our topic. Today, our topic is about the data security, and you can say the secure data transfer. We want to learn about how to make our conversation with someone secure, or how to make the conversation from one electronic device to another electronic device secure. As we know that the information security is a major subject in these days. Everyone wants their message to be secure, and everyone wants their message to be received by the receiver securely without any error, you can say. So today the name of our topic is error detection code. We want to make something, we want to make a strategy which will decide if the message received is free of error or has an error in it. Okay. Error can be an error can enter into your message, or error can corrupt your message, can be corrupted in many ways. The basic issue, or the basic thing which will corrupt your error is noise. Noise is everywhere now. Noise is in sound, in electrical system. So most of the cases when two devices want to communicate and they get a message error, not that kind of error. If they get any corrupt messages from device A to device B, it is mostly due to the surrounding noises, electrical noises, things like that. So today we will discuss a topic which is related to this thing, that how can we be assured that the message we have received, that the device who has received the message, how can that device be sure that this is a message in the original form, or whether this message is corrupted via noise. So let's start our lecture today. Okay. Until now, I have briefly discussed with you that why data security, why message security is important nowadays. And I have also discussed with you that how which thing causes message to get corrupt, to get error in your message. Okay. So, and now I will tell you that what kind of error which can come in our message. In digital electronics, or in binary system, we talk about two things, 1 and 0. Okay, let's suppose this is a message. Okay, in how many ways it can get corrupted? Let's suppose 1 and 0 is the original message. The first way this can be corrupted, that is like this: when this message received by the receiver, it is in the shape of 0 and 0. It means this bit, first leftmost bit, which was 1, is converted into 0 because of noises in the system. Okay, another form, this message can get corrupted 1 and 1. This 0 is converted to 1 due to the noise, due to the error. And the message received at the receiver end was 1 1, which was not the original message. Of course, we don't want this message to get received by the receiver. So what we will do in order to tell the receiver whether this message the receiver received is in the original form or is corrupted. If the message is corrupted, the receiver can do many things. It can discard the message, it can request the sender to send the message again, or it can try to correct the message on its own. These are different techniques. These techniques are not related to our topic we are about to study right now. We just want to detect the code, detect the error actually, that if our message which was received is in the original form or not. Okay, so in order to detect the error in the code in the message, so we, as you can see, in order to detect the error in the message, we use a concept of parity bit. Parity bit, what is parity bit? Parity bit, of course, this bit is not the part of our original message. We will add an additional bit in our message, like this is our original message, and this one is the parity bit, one bit which we have added. Okay, so this bit will tell the receiver if the message is correct or if the message is not correct. So how does this bit work? So this bit work in two fashions. You can adopt any of the one fashion in one fashion in order to detect the error. One is even parity, and the other is odd parity. So what is the difference between even parity and odd parity? Now, let me tell you, if you are using even parity bit scheme on the sender end, you have to apply the same scheme, the even parity scheme on the receiver end. If you are using the odd parity scheme in the sender end, you will also apply the odd parity scheme in the receiver end. Okay, so what does even parity means? Even means, as we all know, even means even number 2, 4, 6, 8, like this. So let's say our message is 1110. We have three ones followed by a zero here. Now here we will add a parity bit. We will add one. Okay, we have added one, so the number of ones are even. So in the worst case scenario, if this message is get corrupted, one of any of this bit will become zero from one or one from zero. Let's say we have two case here. If our bit become zero from one, let's say the middle bit which was one is zero now due to the noise. Our message is like this: we have received the message at the receiver end like this 10101, but our original message was 11101. Now receiver will check for even parity. As we can see, there is no even parity. Receiver will know that this message is corrupted and will can throw it into the bin. Now if this even parity, if we receive a message 11101, like this, receiver will see that our number of ones are zero, are even. Okay, so number of ones are even, receiver will accept this message. So in the odd parity case, same here, we will let our message be the same 1110. So we want to make this in odd parity fashion. So we will add a parity 0, which will make the number of ones is remains odd in this message. And our receiver, if our receiver gets this message here, it will see that the number of ones are odd. It will accept this message. Okay, if our number of this becomes 0, 110 and 0. Now receiver will check that the number of ones are even, but we are using odd parity scheme here, so it will throw it in bin and request the sender to send the message again. Here it will accept. Okay, so in this fashion, we use even parity and odd parity. So let me take another example. If we have original message 1, 1 and 0 and 0. So what the parity bit we will add? We will not add 1, we will add 0. because we have to remain the number of ones even in the message. Now same is the case here. If the number of ones are odd, we will add the parity bit 0, because we have to have the number of ones odd in the message in the case of odd parity scheme if we are using it. Now we know that how we add a parity bit, how our receiver sees the message, how our receiver gets to know about our message, that either the message which the receiver received is correct or not. Now, after the receiver receives the message and after deciding whether the message is correct or if the message is not correct, now we talk about if what happens if the message is not correct. There can be a number of things the receiver can do if the message is not correct. As we have discussed, the receiver can discard the message and request the sender to send it again. Number two, the receiver will can the receiver will try to make the message correct by itself. And number three, the receiver will send a negative acknowledgement to the sender, and so the sender will send the message again to the receiver. And there are many ways to do. There are many algorithms which can help in correcting our message. It will go into the detail, but we will discuss this topic until this thing, even parity, odd parity, how the receiver receives, how the receiver decide. Now inshallah we will meet in the next lecture. Make sure you subscribe my channel. If you like my videos, then you then press the bell icon so you get an update whenever I will post a new video. So I will meet you in another video, in the next video, inshallah. Allah Hafiz.